previous lecture, when we had changed this particular contacts, I had to change this particular say formulation from program control to augmented Lagrange. So why we have selected that particular formulation? Because by practice this particular formulation holds good for solving frictional contacts. So that is why I have selected that manually instead of leaving that particular option to the software. And now after finishing this, we are going to generate the mesh. So, and we are going to generate the mesh and see if the mesh is good or not, and if it is not good, then we are going to try to use some localized controls. But here see, with the automated mesh itself, this particular software has refined our mesh at this particular edge, so we need not say further refine the particular mesh. Now what I am going to do is I am going to just right click and say insert, and then I am going to go say I am going to select the frictionless support, and I am going to apply the frictionless support to this particular edge and to this particular edge as well, and I am going to say apply. And once I have applied this frictionless support, then I need to apply the force. So for that purpose, what I am going to do is I am going to right click on the static structural, say insert, and in the insert I am going to select this particular force. So once I select this particular force, I am going to select this particular edge and I am going to apply, and I am going to, instead of going for vector, I am going to select the component system. In the component system I am going to give it my 10,000 minus 10,000 newtons. So because it was given 10 kilonewtons of tension, pre-tension, so I am going to give some 10,000 newtons. So once I have entered that particular value, see, it is going to drag it like this towards the downside. So now what I need to do is I have given all the required boundary conditions, contacts and other forces. Now I need to solve the problem. So for that purpose, what I am going to do is I am going to just right click and say solve the problem. So while solving the problem, I will tell you one thing that so we have applied a load. See here, no problem, it's not a big problem here. So once you have applied the load of 10,000 newtons on this particular line, what happens is the software is going to divide this particular value by the area, and then it is going to take up the pressure value. For example, here this particular radius is 20 mm. So what happens, the total area of the circle here will be pi by 4 into 20 square. 10,000 divided by this particular value will be giving 31.83 MPa. So if you have taken it this particular body in 3D, you would have selected the bottom face, and once you have selected the bottom face, you would have applied a pressure load of 31.83 MPa instead of the 10,000 newtons of force. So if you have a pressure value and you need to convert into line pressure value, what you need to do is you just multiply this particular pressure value into the area on which you want to apply, and that value which is going to yield is the value which you are going to apply as a line pressure instead of a area pressure. Then once we have done all these things, we are going to right click and say insert and say deformation, and I am going to say total deformation, and I am going to evaluate the results. So once I evaluate the results, I can just animate the results here. So see, it is trying to move downwards due to the force, and it is applying some pressure through this particular contact surfaces to the bolt as well, sorry, to the nut as well. Then you can also find out the stresses like radial stresses, axial stresses and other sorts of stresses here. You just need to right click, say insert, go to the stresses and then select the normal stresses, and then you give the orientation to x-axis, which is nothing but in the radial direction. So you will just rename it as radial stresses, radial stress. Then coming to other type of stress, which is stress, say insert, then go to the stress, then select normal stress, and then instead of the orientation to x-axis, you can change the orientation to y-axis, because this y-axis is going to coincide with this particular axis of this bolt or nut. So I am going to rename it by pressing F2 as axial axial stress. Then if you want to find out the circumferential stresses, you don't have the z direction in 2D, so you need not say define a circular coordinate system here. You just need to right click, say insert, then you can say normal stresses, select the normal stresses, and in the normal stresses you just rename it as hoop, and then you change the axis to z, and then you just right click and say evaluate all results, so that you can find out the values, radial stress values, axial stress values, as well as the hoop stress values. So this is how we can perform an axisymmetric analysis on a bolt and nut. This is not only limited to bolt and nut. If you see any cases where there is axis symmetry, you can just remodel that 3D problem into a 2D problem, and you can solve it like this. So in the next lecture we are going to see how we can say take a 3D object, then convert it into 2D object, and then perform analysis on it. Thank you.